Hello everybody. I'm Bane Igbango Martin Ushayamba. I may like to welcome all of you to this great channel. The name of this channel is Us Best Series TV. The purpose of this channel is to educate people in the field of electrical and electronics engineering. That's the main purpose of this channel, ranging from this do-it-yourself simple project to complex ones. I'm not perfect enough, but I'm an amateur in this aspect, so I may like to share my knowledge out to the general public, and I may like you people to just join me. Let's join hands together to elevate the nature of education, especially in the field of electrical and electronics, to the younger ones or the society at large. Though I've been publishing some movies like that, but I'm here to show my face into some movies like that. That's why I may like to interact with you people, so that you may know me one-on-one, that this is who I've been sending things to you people out there to watch. Thanks for being with us. Thanks for your support that I may get from you. I may like to urge you people to please like this channel, and each and every time I post, comment. That will take us to a greater height. Thank you so much for being with us. I didn't have much to say, but it's to welcome you people to this great channel. Thank you so much. Just do us a favor by subscribing to this channel. Thank you so much for watching this video. Here we have some electronics components. We'll be testing them one by one to know their working principle first, before we embark on producing something with them. In short, let us see how they used to work. First of all, for easy handling, I will now fix them on my circuit simulator, which is the breadboard for easy handling. Stand by. Arrange the breadboard this way. First of all, let me begin with a resistor. Here is a resistor. You can see it very well. Let me put it there so that it can be clearly seen. Here is a resistor. You can see it very well. Yeah. Now for you to test the resistor, first of all, need to hold it this way. First of all, on your multimeter, switch it to continuity test. If you have done that, test your multimeter probes and see whether they are working normal. You can see there is nothing wrong with it. We are good to go now. Yeah, I can now hold my resistor this way and read. You can see the reading. Most resistors may not read on this continuity test, reason being that the resistance may be more greater than the resistance on the continuity test there. So if any case of that nature occur, you can switch it. You keep switching it till you get the accurate distance you are looking for. You keep switching. You keep switching. Just watch and see what is going to happen. You see, as the resistance of the multimeter being greater than the one of the resistor, you see it start counting in zeros. That is to tell you that now the resistance of the multimeter is now greater than that of the resistor. If I switch it now to 200 million, now you see 0 0. You see 0 0 0 0. That's to tell you that the resistance of the multimeter now, of the resistor now, is less than that of the multimeter, which is not what we're looking for. You can see it's working normal. Just in some cases you see the resistor will not work at all, proving to you that it is bad. Or it may not work, it may be due to its resistance being greater than the value which the value in which you have selected on the multimeter. So now let's measure this one and see. Before measuring your resistor, make sure you hold one pin of this way, and the other should be left freely so that it not touch your hand, because if it dare do, sometimes you may have an incorrect reading. You see the resistance now is less. You can see the meter beeping, but it's not that the resistor is bad. That's to tell you that it's a resistor with small value. That's why it reads with red light. We can now switch it to 200 ohms to get the accurate distance which we are looking for. It's 11 pound. That's 10 pound. 6 ohms like that. If I switch it to 2K now, you see it now start counting with 0. That's to show you that the range in which I put is greater than the value of the resistor. If I now switch it to 2K now, you can see 0, 0. Likewise all the resistors. Let me try the one with the higher value for more reality. Like, let's try this one. You now see what I'm talking about. It does not read on the continuity test there. If I switch it to 200 now, you're gonna see no reading. Switch it to 2K now, you see no reading. Switch it to 20K now, you see no reading. Switch it to 200K now, you now see that's the range at which it falls. That's to show you that it's a resistor with greater value. If I now switch it to 2 million now, you're gonna see it begins with 0. That's to show you that there is less. So that's how you can follow and test all the resistors. With this, you can test and know their values without the stressing to calculate with their color coding. We will now test the capacitor and see. Testing capacitor is where you can switch it to the continuity test again. While testing a capacitor, it is expected that it toss up and it reaches to a value and decrease immediately to show you that the capacitor is working normal. If it continues reading, that's to say there is something wrong with the capacitor. Or if it does not read completely, it still indicates that something is wrong somewhere. So now you're gonna see, put the probes one side, make sure it does not touch your hand and touch the other side. You see it reads and runs down completely immediately. That's to tell you that the capacitor is working on it. Can charge and discharge. You can now, I will now turn it the other side. You see it reads and runs down immediately. That's to say the capacitor is working normal. I will still switch it and you see. You can simply do this to know. And we have various types of capacitors. This one is electrolytic capacitor. Put it there and put it that way. This is what is known as Mika capacitor. You can see it very well. Mostly found at power size of circuits. This is a Islamic capacitor. Islamic capacitor. You can see it very well. It's Islamic capacitor. This is it. You can see it very well. We have polycrystalline capacitors. It's a polycrystalline capacitor. You can do this one too very well. Yeah. Now we have integrated circuit. This one is an IC, a chip. You can see it very well. So it is known as chip. Now we'll be testing a diode. From the diode, we get the working principle of a transistor. Let's begin with the diode first. Testing a diode, you got switch your multimeter to continue test again. The diode has mark. It has a band on it. You can see it very well. This band here indicates the cathode of the diode, which is the negative side of the diode, and the black big section represents the anode, which is the positive of the diode. So the diode acts like a valve in the human body. It conducts only in one side. That it allows electrical current to enter the anode and to the cathode only, and it does not permit in the other way around. If in case a diode reads in the other way around, then the diode is not good completely. On the normal knobs, a diode is supposed not to read that way. Let's test it and see now. You now put the negative of your multimeter there to the cathode, and then this one, the positive to the anode. You can see that the diode reads perfectly. If I now switch it, turn the anode of the diode to the negative of the multimeter and test, you will see no reading. And if it reads, then there is problem somewhere. You got to check. These are the simple things we gotta do. We'll now be testing a transistor. We have, like here, we have BJTs and FET or MOSFET, depending on the keys in which you are embarking on. Like this one, like this is a bijunction, a bipolar junction transistor, BJT. You're gonna see it very well. For easy handling, I will now insert it on my breadboard here so that I can handle it more perfectly to get accurate, what I'm looking for, like this. I'll put it this way. I will now insert my connectors to match. When I insert my connectors to match this, you're gonna see connect them to match this. Connect it this way, or let this one be here for more clarity. Even though if they are on one line too, it will still work, but I'm avoiding the situation where they will be choked together. So that's why I'm arranging this way so that you people can see it more clearly. Yeah, I'll fix it this way. Carry this one, fix the other way around like this, but you see it still perform the function in which we intend anyway. If you want to know that it is well connected inside like that, let me see here. I will first of all put this one, put it the main leg of the transistor. You see that it is connected. If I put this one to the other side, you see this one is not connected, so make sure it enters inside well. Make sure it enters inside well. You're gonna see something now. It's now, but testing now, you see if it didn't read, then something must be wrong as well. On the norms, it's supposed to read, or maybe it's the props of this multimeter. You're gonna see, yeah, it reads. If I take this one to the middle one, and you see it is still read. Then we are good to go now. Like this one, this very transistor here, so it's an NPN transistor. It's an NPN transistor. You're gonna see this. Yeah. So now, if I connect this one here now, and test the side, you see it will read If I now take to the other leg, you see it will read normal. NPN means that the positive of the diodes are interconnected this way. This forms the anode and this very one so forms the cathode. That's why if I put the probe of my multimeter this way, you see it reads. Understand? But current flows inside normal. But if I now interchange and bring the negative side of my multimeter here, and then you see no reading, proving to you that the transistor is working normal. And if it does not do this, the transistor is not in a normal state. I can now test it with this very one. So what you see, design effect. You see design effects we are looking for. I'm gonna put this one this way. You still see the same thing. By this, we're gonna differentiate. We're gonna know the ones that are NPNs and the ones that are PNPs. We're gonna still know here. We're gonna know. Just make sure everything enters inside where. If I now test from here, we'll repeat the same principle and see. See, this one too is an NPN transistor. So you get what I'm saying? Yeah, you can see this very well. This one also is an NPN transistor. And we can likewise do this. If you didn't want to use the probes of your multimeter, you can now switch this range, this selector now, to this HFE. From here we can detect and know whether these transistors are working normal. We can know their class, whether NPN or PNP. Understand? You can see the indications here. You can see the indications here. You can see HF like this. That's the indication. From here we can know. Understand? First of all, I turn it this way. Turn it to face. The one with written alphabet should face this way. If I now insert it inside, you're gonna see. You will see something. No reading. No reading. Remove it. Shift it up. No reading. That is to prove to you that it is not working from the side of PNP. That the transistor is not a PNP transistor. Now take it to the NPN transistor. Put it, let's see. You can see it does not read. Reason being that you didn't put it the right way. Move it and put it that way. You're gonna see that it now reads normal. That's to prove to you that this transistor here, so it's an NPN transistor, while this side is its emitter, the base and the collector as indicated here. So if we fix it, then you can know. This is what is known as lead emitting diode, commonly called bulb, an electric bulb. Now I'd like us to test the potentiometer, which is a variable resistor, and know how it varies its resistance when the knob is turned. We will now fix this one now on our circuit simulator like this way. Let me put it here so that this wires match it down. Put it, let it cross the other side. Then you will now put your connector this way. It's the basic understanding how to couple this down. You're gonna put it this way. So now let's read it and see. You choose one of its sides to read and forget about the other one. Understand? Try it this way and see. Try it this way. try it this way. Switch this one there, and you're gonna see we're good to go now. Let me connect it this way. Understand, right? Then I hold this one the other side. You can see as the meter is beeping. If I now turn this knob now, you see as the resistance is increasing there. Watch the multimeter and see what is happening. Let me switch this wire. You see the meter stop crying now, and you have a reasonable reading. If I keep turning it, you get to a certain point that you discover that the meter won't read again. To show you that the resistance is more than that which the meter offers. You can see that one is not in tune well. Let us use this one for easy manipulation. Stand. I can use this one and turn it. You see as the resistance is increasing, you can now see it's about 1,395. If I screw this one back now, you see it will keep decreasing until it will get back to some hundreds, and then back to zero. You're gonna see now as the meter cry. If I increase it, you're gonna see the same thing. It's the basic operation of the multimeter of the variable resistor is to out and reduce the value of an electrical signal. You can view it very well. This is it. Yeah. In our next video, we're gonna learn how to network all these components together and make a reasonable circuit. Yeah. For now, in our next video, that's what we're gonna do. How to network these components and make a reasonable circuit. This one is simply a piezoelectric transducer, the one that makes a beeping sound. Though there are various other components that were yet to touch, but as time goes on, we're gonna get in touch with everything. This is just the beginning.